All right, last example here for 2-3, number 5. So this is kind of a hot mess because there's a lot going on. We've got fractions, we've got numbers, we've got exponents raised to other exponents. So you might be a little overwhelmed and you might be wondering where to start. Well, over here, okay. Come on, computer, you can do it. So where to start? When you're looking at something this crazy and this overwhelming, the best thing to start with, and what you shouldn't, it's kind of like order of operations. You're starting with any exponents that are raised to any other exponents, hence those parentheses. So that's exactly what we're starting with here. We're going to deal with those exponents raised to the other exponents. So in my top of my numerator here, I have all of this stuff inside these parentheses being raised to the second power out here. So again, when I'm doing exponents to exponents, that is multiplication of the exponents. Or again, you're just expanding it and doing it that way, guys. So 2 to the second power squared would turn into 2 to the fourth power because 2 times that 2 is 4. X to the negative 3 squared would turn into x to the negative 6. 2 times that 3, negative 3 is negative 6. Y to the fourth squared would be y to the fourth times y to the fourth, which is 4 times 2, 8. And z squared times z squared, 2 times 2, gives you that 4, or z to the fourth. So there's my numerator. Now in my denominator, notice not every single piece there is being raised to that cubed. Only the things in the parentheses are. That 10 is not being raised to that exponent, so that 10 is just going to carry along with us out here. So now inside, again, I have exponents to exponents, so that's multiplication. X to the 0 raised to the third power, 0 times that 3 is 0. My y, remember, does not have an exponent of 2 like the z. The y has its own exponent of 1. Z to the first cubed, 1 times 3 is y cubed. And now z squared raised to the third power, 3 times 2 would give you that z to the sixth. All right. So once we did those exponents raised to exponents, it's really up to you to decide where you want to go next and then just simplify. Rather you're simplifying the divisions first, or you're dealing with negative exponents, or you're looking at the numbers. It's all got to happen sooner or later. So 2 to the fourth is 2 times 2 is 4, times 2 is 8, times 2 is 16. Or again, put it in your calculator. So we have, I wanted to stay red, we have 16 on top. X to the negative 6, that's a negative exponent. No me gusta those negative exponents. That's got to get pushed down to the bottom. I still have 10 on the bottom, though. So x to the negative 6 on the top goes down to the bottom and turns to a positive. My y to the 8th can stay on the top, as can my z to the 4th, because those are both positive exponents. Now to my bottom. X to the 0, remember anything to the 0 power just turns right into 1. X to the 0 is equal to 1. So I can just put times 1 if I wanted to. And then my y to the 3rd and my z to the 6th, they can also stay down there because they're positive. Actually, let's change these steps. Let's say instead of just simplify, let's go to deal with negative exponents next. And then, last but not least, do that final simplifying. All right, so let's keep on keeping on with this guy because we're not quite done. So 16 and 10, both of those I know that I can simplify by 2. 16 divide by 2, 10 divide by 2 leaves me with 8 over 5. And again, I still have this giant fraction. You never want to have a decimal inside of a fraction. Like, I wouldn't want to have like 0.5 and then that in a fraction, because 0.5 is the fraction 1/2. So like your 8 just stays on the top, your 5 stays on the bottom kind of thing. So I don't have any other x's. So my x to the sixths are going to stay the same on the bottom. But my y's, I have y to the eighth on the top and y to the 3 on the bottom. If I were to expand that out, 3 of those y's would cancel out, leaving me with 5 y's on the top. And that makes sense because I had more y's on the top than I did on the bottom. And now with my z's here, let's look at our z's real quick. If I have z to the 4th divided by z to the 6th, that would be 4 of those z's on top, 6 of those z's on the bottom. 1, 2, 3, 4 of them canceling out, leave you with z squared, but it has to be on the bottom. So there is our final simplified answer. I have no more like bases. I don't have any numbers with exponents that I can simplify. So take your time on these problems. Make sure you're using your notes. They are a little bit complicated.